Hi, sixth grade. This last video on volume is going to be about finding the volume of an irregular solid. And so what we mean by finding the volume of an irregular solid, or what we mean by an irregular solid, is something that we can't easily find the length, width, and height of. So this round object here would be considered an irregular solid. My food coloring bottle, irregular solid, because we're not going to have just one length, one width, and one height. So you're actually going to have to take some of the information that you've learned on using graduated cylinders and finding the volume of a liquid and put it together in order to find the volume of an irregular solid. So believe it or not, we are actually going to be starting off with a graduated cylinder. So we want to fill, and I'm just going to abbreviate graduated cylinder GC. So fill the GC with enough water to cover the object. So there's not like a specific amount. It doesn't really matter what number you start off with. So I just kind of usually hold my object up here. So it looks like I'm just going to fill it to like 15 milliliters would be enough to kind of cover this object. And so this is where you would use your pipette as well to kind of get an exact measurement here. I'm going to try to do this. Remember, you need to be doing this on a flat surface, but I'm going to do this so you can see what's going on with my webcam. So I have 15 milliliters of water in there. So we're actually going to be using a formula for this one. And what it is we do volume, and then I just always put a little subscript of the letter that I'm trying to find. So we're just going to put B for ball because that's what I'm trying to find. And how I did that, the shortcut to get the subscript is Control, comma. So that's how you do that. Equals, and we're going to do our volume 2 minus our volume 1. So again, I come down to my next step. Volume 2 would be the second volume that we're taking. Right now, this is the first volume that we're finding. It's the volume of our water by itself. And so I know that I started off with 15 milliliters of water. So that's my volume 1. See how I'm subbing it in right underneath there. Now, how I get my volume 2 is I'm carefully going to drop this item into my graduated cylinder. So I'm going to kind of angle it. I don't want to splash my, oh, I didn't think about this. My ball is floating. Let me go get a marble. Okay, so I have my marble here. I'm going to carefully roll it down in there. So once I dropped that item into my graduated cylinder, you're going to see that that level water actually rose because the marble is displacing the water. So it's pushing the water out of the way. And the amount of water that's getting pushed out of the way is equal to how much space that marble is taking up. And remember, volume's measuring space. So if we can figure out how much water that this marble pushed up, we can figure out the volume of the marble. And that's why we're doing a subtraction, because we're trying to figure out the difference between the amount of water that we started with and then the amount of water that was pushed out of the way. So if I get my volume here, it's going up 2 milliliters. So we're at 17 milliliters now. Remember, you would have done that on a flat surface so that you could get at eye level. I made sure that that was level there. So our second volume, or V2, is 17 milliliters. See how I fit that into my formula? So I'm just substituting it in for this variable here. So my second volume was 17, and then all I have to do is just subtract. 17 minus 15 is 2. Now, we know that we use units milliliters for liquid, but we're not actually finding the volume of the liquid now. Once we've subtracted, we found out how much space that marble was actually taking up. So we're talking about a solid. And the units that we use for volume of a solid would be centimeters cubed. Why we can just flip-flop our units like this is because of our conversion factor. And I know that you guys have been converting units with Mrs. Signs, and this conversion factor is so super easy. 1 milliliter is the same as 1 centimeter cubed. So we can use milliliters and centimeters cubed interchangeably because it's a 1-to-1 ratio. So that's why we kind of flip our units here. So up here, we were finding the volumes of the liquids, but once we subtracted them, we were actually finding the volume of a solid, which is why we changed that unit. So the units that we're going to be using are going to be milliliters first, and then changing it to the centimeters cubed. And then our tools that we're going to be using are just our graduated cylinder. So if we go through these steps one more time what I did, the first thing that I did was fill the graduated cylinder with enough water to cover the object. And I want to determine the volume of the liquid that I put into that graduated cylinder. I'm going to carefully drop my object into the graduated cylinder and determine the new volume of the liquid. Then I want to subtract the original volume of the liquid, so that was my V1 that I put in over here, from the new volume, or the second volume, and that was my V2 over here. So this number is the volume of the object. Okay, and so that finishes out your notes here. You're going to do 2 practice problems, actually finding the volume of different irregular solids, and then you guys will do some just review over finding volumes of all of these different objects. So I know finding the volume of an irregular solid is probably the most difficult, so if you do have questions, make sure that you're making an appointment to conference with me.